All right, so yeah, let's do this. Let's pick the information tool at the top. Yeah. So bring your mouse to the top toolbar. Here, you see this eye thing here, an arrow with an information.
Yeah.
Here. That, and then I want you to click anywhere in the image. Click anywhere. And when you do that,
yeah,
you look on the right, and you should see the results. Identify results.
Yeah.
Somewhere on the right hand side for me. Now you see that the value DEM. You see the value there.
Yeah.
It's actually 1558. So that's supposed to be the height value at that point. I mean, I don't know whether this is above mean sea level or what, but that value is actually the height, or if not the height, it's really the value that we can associate with the surface, with a surface. So this is a surface. So obviously when you look at the black areas, the values there are not that, they are lower values. And so I'm actually clicking on the black areas, which is supposed to be like some kind of a creek or a passage for water. A channel. Going to. Now the whiter the values are, the higher the values. So this is what we call the grayscale. In the grayscale, values kind of vary from pure black to pure white. You have the gray. That's everything. Are you all right? All right. So this is the typical DEM. The values on the left-hand side on the panel, the layers panel, shows that the minimum value is 149 and the highest value is 2647. Are you okay? All right. So now with this, one of the basic things we can do is to go to the raster menu, and then we can actually go to analysis, and then let's look for slope. Look for slope, because I talked about slope and aspects. We start with slope and go for aspects.
Yeah, we're here.
Yeah, very simple calculation. We're just gonna have results. Just click it, and then you just have. But you need to understand what it is. Okay, so just run it. You don't have to do it. All right. So now we have generated a new surface called the slope surface. Are you okay? All right. So the values are ranging from 0 to 68. Are you okay? All right. So because it's slope, I think it should make a bit of sense what these are. Are you okay? That now it means that the value, the higher the value is, the higher the slope, isn't it? All right. Okay. And if the value is 0, then we get what? We get 0. It means that there's flat. There's no change, right? It's a flat area. So obviously you can see that down deep within the thing, there are some flat areas which are actually having 0 values. Okay, and then we have the higher slopes will always be, if you compare this initial surface with the newly created surface, then a place like this here, okay, actually had
most of them.
It had a very high elevation value, 2, 4. So you can imagine that if water falls, the top of a valley, the slopes there are very high. Are you okay? So the slope, the value is supposed to, the slope there is supposed to be very high, 62. Are you okay? And then we have a high elevation value too. We can also generate, so let's switch off the slope surface. We can also do our aspects. Okay, so instead of picking slope, pick DM, not slope. All right, and then you want to find the aspect of that. You don't need to, don't touch any other thing. Are you okay? But we have so many options. You just click run in background. Okay, so now this one is also interesting. But what does this? Who can interpret this for us? Please, who is talking now? Who is talking? Please. We can't hear what you are saying. Please, what are you saying?
I was not using clay soft that time. No, I'm using clay soft to bath. Clay soft, clay soft.
And I'm trying to mute you. The meeting is not working.
Hello, sir.
Yes, who's chatting? I don't know what this person is saying. Okay, let's carry on. What is this surface? What does it mean? This is an aspect surface. What does it mean? What is the interpretation of this according to the lecture?
It is giving us a pictorial view of how the place looks.
No.
Where we have the
No,
high point.
No. So we talk about the slope surface. That the slope surface shows us the rate of change from cell to cell. Are you okay?
Yes.
So the rate of change from one cell to the other, that gave us the slope. So let me turn off the aspect. Let me put on the slope surface. So this one, it doesn't look very nice and sexy, excuse me, but it's telling us something that there's a certain change. And this thing keeps on coming up. What does it mean? Okay. So it's telling us the value, the rate of change. Are you okay? Okay, let me actually get it. Slope. You need to select the layer before you actually identify. So the value here is 58. So the rate of change varies along, a terrain or a surface. Are you okay? All right. So we understand that. So it means when water flows, the flat areas, the black areas, the areas with black are likely to have water staying there because it's flat. Are we good?
I don't feel they go the other time now. Like,
Can I remove
the room now?
So that is hey, what's his name?
I've put him in the waiting room, so don't worry. Don't try to remember his name. So so now here we are. This surface shows values that are actually like rate of change. Are you okay? I think we understand rate of change. Like example, speed. Are you with me?
Yeah.
So slope is actually dy over dx. That's how slope works. Are you with me? Gradient.
Yeah.
All right. Now aspect. What is aspect? Anybody to help us? I've already said it in class. What is aspect? What is this surface? What does it mean? What is it? Okay, so I'm selecting values for
It has to do with the resolution.
Please, I think that class, you guys didn't pay attention, but look at the values on the right hand side over here. Please, exam is coming, so let's be serious.
Hello?
Look at the values here, okay? Please, if you are making a call, mute yourself, otherwise I'll take you to the waiting room. Okay? So now, look at the values here. Can you see my pointer? 184, right? Now look at it, it's changing. Look, what do you think those values are? If you're an engineer, honestly, you don't do much. You don't push the wheelbarrow. You don't clean the sites. What you do is I just think for them. Are you okay? So please, that is why I ask you a lot of questions. What do you think these values are? What surface is this? This is the surface that shows the direction of the slope. Are you okay? So all the values are between 0 and 360, because it's really about direction. The values you are seeing here are really values about the direction of the slope. Okay, so let's look at this whitish area. It's actually 273, means that this surface here actually is pointing in the northwest. Are you okay? Northwest. 270 is northwest. So a little about that is northwest. Are you with me? Okay. So that is what this surface it's all about. This one is 11. 11 means it's pointing around the north. Are you okay? And a little bit to the east. Okay. And when you actually look at the surface very well, you can actually agree that with the values that we are getting are correct, because normally our north is in this direction. North is always like that. Are you okay? So you can see that we have a very good result. It's reliable and it can be used to make some decisions, like in terms of size selection, etc. Okay, so that is basically what I can show you on this one. Okay, let's switch off the two derived surfaces. Let's assume we are putting, let's see an application of this one. Let's assume I wanted to put up a building, but I don't want to put it where a certain side of the slope will be seen. I think obviously this data will go a long way to help, isn't it? Right? Because it shows that the direction in which we are facing. So where can we be seen? So this links up with the view shed. Remember we talked about view shed. All right, great. So let me actually put in the road data and let's look at some road data. I think I've sent that to you as well. So we can switch off our aspects, our slope. We can close this one, save it, or we can open a new instance of QGIS. All right, I prefer to open a new instance because, excuse me, some of you are actually learning GIS for the first time. The very first time. So I'm going to get my road data. I think I sent you a data called roads, isn't it?
Yes, please.
All right. So look for it. Let's all look for that data. First, you look for it. Then when you need to actually, Ngoma, are you doing it or you're just smiling? I just saw your face.
Oh, no, sorry. I just said to my brother to move on because I'm watching the video. That's why.
Okay, that's fine.
Oh, okay.
That shall not be cut. Anyway, no, it's like I'm just playing with you anyway. Yeah, what can I do?
I know.
Yeah, I'm only playing. Okay, roads. Let's look. I'm looking for my roads. I haven't even downloaded it. I just send it to you by myself. I have to download it from your WhatsApp. Where is it? Okay, DM roads. Okay, so I just got my roads. Data is zipped. You have to unzip it as we said. So I click it, extract to roads. And you have the roads folder. Open it up. Then you look for the SHP. You can drag it there or you can go through the process. Layers, add layer. Are we good? All right. So let me actually my new instance of QGIS, fresh version. All right. So please, guys, let's add the roads.shape. It's a shape file. So we are back to vector. So the DEM was raster. All right, should have been a satellite image. But let's all add the road data and let's look at it quickly. In fact, we are ending the tutorial on this one. I realize that you can just keep going on and on and on and on. And there's a lot that you can do. Are you okay? There are loads of tools available. It's a wide range of things that you can do. Are you okay? So, but per one course like GIS application, you can only do so much. Are you okay? So I want you to simply add the data, and then if you have a challenge, let me know. If you don't have a challenge, you can also let me know.
I have a challenge.
Okay, what's the problem, sir?
When I bring in the file, it tells me invalid data source.
Okay, invalid data source. How are you actually taking it in? Means you have
Your
put the
computer
wrong
is not good. Go and throw it away.
Keep quiet.
yeah, keep quiet. Let's help him. I think you put the wrong data set into it. Is that okay? You put the wrong extension.
So you said the root.shp.
Yes.
Yes, that's what I used.
And so then you shouldn't have a problem. You say your data source is wrong. So when you have to have a number of files, PRG file, SHX file, DBF file, make sure all of that is what present. All of them are present. Are you okay?
Yeah. DBF, ERJ, QIX, QPJ, SBN, SBX.
So many of
And we
them,
have
isn't it?
Yes.
Yes. All right. So try it again. Just delete it and do it again. Is that okay?
Yes, sir.
It's always good to do that. All right. So first, let's play with our topology tool. Let's play with our topology tool. Once you are done, let me know. Please, we are waiting for you. If you are stuck, so let us know if you are stuck. Okay.
So if you open yours, you can continue, please.
All right. Okay. So
I don't
here we are with the topology tool. Let's see. So topology should allow you to actually check if your layer is okay in terms of the lines, whether they are meeting at the right places or not. Are you okay? Because when you look at this data closely, you go in for the zoom in tool and then you zoom in. Okay, this is possibly Tetekwashi or one of those interchanges, but you see these kind of issues that you're having over here. Are you okay? Let me get my spotlight. Yeah.
So your data is not opening now.
Say what? My data is not opening.
Yes, we still have the DEM file.
The routes.
File. Yeah. The root is not there.
No, I want you to actually start a new QGIS. I said that you could put it there, but I don't want you to load everything there. So open a new one. Okay, if you can't see it, right click the layer on the left hand side, and then click on zoom to layer. It will take you there, but it's a very dangerous thing to do. But try it. Why? Because you may be working with different coordinate systems. Are you okay? And that is where you have the problems. Okay. Are you good? Have you been able to do the zoom to layer? Have you done that? Right click it and zoom to layer. Have you done that?
No, sir.
No. Have you done that?
So I should right click from the folder.
I want you to right click on the panel, the left hand panel. Here, you see this one. You've actually opened the rows data where you have the DEM, isn't it?
No, I closed mine. I closed the DEM.
Fine, but you have the routes. We are working with the routes. Do you have the routes now?
That's what I'm trying to do, and it's telling me my data source is something.
But you told us that we should carry on. I wanted to see what help you, but you said we should carry on, isn't it?
Yes, let's carry on.
So that's why I've left you.
Let's carry on. I'll work on it later.
But what you have to do is that, just do it all over again. Open a fresh one, and then go to layer, add layer. Are you okay? Add vector layer. Okay. And then look for the rows data. Mine is in downloads. Okay. You open it up, SHP, and then you just click it. It opens it. Just say add. You see now I just done it. It's very simple. I just did it away. Yeah. Please. All right. So now just add your road data and then click on vector topology checker. Are you okay? We just want to see, play with it. And I told you that the topology is supposed to take care of overshoots and underhangs. Like I'm saying, there's no road around any intersection that goes and just ends. This is a dead end. How can you have a dead end in the middle, are you okay, of an intersection? It means that it's just a digitizing process that hasn't gone well. And we see a lot of, you know, dangles, lines that are just hanging. Normally it's a network. Roads are always networked. There are only a few, you know, roads that, what do they call them? Roads that don't come, that you can't continue on it. What are they called? They are called closed. Are you okay? It's a close. You go in, you never come back. Are you okay? So what we want to do is to just use the topology tool and see, you know, what we can get from it. Are you okay? So the first thing to do, let's click on vector and then topology checker. Okay. And then we just, you go for the tool. It opens this dialog box. Are you okay? So now we can remove one of the roads. We don't need the two of them. For me, I'm having two. I think all of you need to have one road layer.
Sir, hello?
Yes.
Your interface is still showing the GEM.
Okay, sorry, I'm not sharing my screen. That's what it means. Yeah, sorry about that. I think that is why I keep on getting a message that I need to get something out of the way. Okay, so are you seeing the routes now?
Yes, sir.
Great. Okay, so now this one looks
about that.
okay. No, I haven't gone anywhere. I mean, I'm not going over like, you know,
Just
when you
read.
say to a teacher, go all over. I think it's easy. I'm not going to go all over. Everything I said is still valid. Yes. So we all have to zoom to this place. Are you okay? Because you knew that you were not seeing it. You didn't tell me. All right. So you should have told me earlier. So I'm just going to get topology checker. You try to get a configure button. Are you okay? And then finally we'll validate. Validate, check if you have anything that doesn't meet the rule. Are you okay? All right. So let's look for the topology rules settings. So it's the settings based on which we actually, you know, do the actual topology checking. Are you okay? Now look at it. One of the rules here. Endpoints must be covered by. Are you okay? So the endpoints are like the nodes, isn't it? All right, so endpoints must be covered by, we can say, another layer, but we don't have any other layer. Must not have dangles. Okay, so that one is what I just talked about. Dangles. Are you okay? Dangles are like overshoots. Are you okay? So let me move away from this dialog. I'll come back to it. I picked it from here. Let me get my spotlight again. Okay. You see this tool? After you open the topology checker, all right, you can always come and click this spanner icon over here, and then it opens the settings. Okay, but I want us to move away from the setting for a minute. We come back to it. These are the dangles, because if people were not seeing this one, you didn't tell me. All right, so I've said a lot that you didn't see. These are actually dangles. Like I said, a road network is supposed to be a network. So the roads are actually connecting. So I'm moving from one point to, I can't just go and get stuck. There's nowhere to go again. That's not a good road network. Are you okay? There are only a few places where you go, you can't come back again. All right. Legally, there are only a few close, what do you call the close? I don't know, there's another name for it, but maybe we can find it later. All right, so we are going to set rules here. And one of the rules is that when we pick a layer, this road layer, we can see that it shouldn't have dangles. Are you okay? Then we add a rule. So rule number 1 says you shouldn't have dangles. in a new. Okay, so let's take that to be the only rule we have. Okay, so topology handles that as well. And then let's validate. Oh, so now you can see that we're having so many of them, isn't it? Please, are you following? Is the class still alive? Are they there?
Yes, sir, we are here. We are listening.
Well, yeah.
Are you follow? Are you doing what you? Are we all doing it? Yeah.
No, sir.
Okay. Okay. I think now I'm the only one doing anything. So I think I'm finding a nice way to end it. So this is the results of checking for topology to find out loose ends of the network. Over here, we don't have any dangles. So this is a typical looped network in the middle here. Are you okay? So we don't have any dangles here. Nice one in this box, right? And you can find other places in the network where we don't have a lot of dangles happening. Where there are a lot of dangles, it's not really a good sign. It tells you that there's a lot of work to be done in terms of cleaning up the data. Are you okay? So for every network analysis, this is one of the basic things you need to do, is to check for topology, especially connectivity. Are you okay? And those things. It's very important. Okay. So let's see whether there are other interesting rules that we can actually use in this box. So instead of having, let's use a layer.
Hello, sir.
Yes.
Before you continue.
Yes. Let me
Yes.
So now,
Yes.
yes, go ahead. I'm listening to you.
Yes, I'm saying, what if the dangles are actually
if they can be valid, yes, they can be okay. I know that's what you want to find out, if they're actually like that, isn't it?
Yes.
But like I said, in real life, roads don't you don't have too many dangles like this. This particular data set, you can see there are too many dangles, isn't it?
Okay.
Look at it closely. There are too many. It's work that wasn't well done. Are you okay? It's work that wasn't well done. So what you would do it naturally is that you will actually overlay this whole thing with some kind of satellite data. Is that okay? And then when you actually add the satellite data, then you can actually tell that, okay, this is where the roads are supposed to be. It shouldn't be dangling. Okay, here I see a dangle here for real. Are you okay? So this is a dangle. These are correct dangles. Are you okay? Because I can even see that even Google has accepted that. So maybe, yeah, like you're saying, yeah, we don't have to worry about that at all. But another thing that we can do is to actually do other ones. It's not the dangles only that are a problem. We can pick the road data and find out if they must not have invalid geometries, for example. So an invalid geometry will be, maybe it's not, we are having a line data, but what we are having is not really a line data. Are you with me? So must not have invalid. Let's add that and see what happens if you run it. You say okay, and then validate everything. And when we zoom to extent, zoom full, it's okay. It doesn't have that issue. Or everything we have is a line data. Okay, we can go and add another rule. And then we say must not have pseudos. Okay, we can look at that. Pseudo means false, invalid geometries, duplicates. Let's try duplicates. Add to, okay, let's validate all. Okay, so far it's like I see the data has passed. Are you okay? We're not having any errors, except for a lot of dangles. Are you with me? But that is how topology checking works. And because we have line data, the topological rules are different. If we had polygonal data, there will be a different set of rules. Are you okay? For example, polygons share boundaries. Are you with me? All right. So in conclusion, before you do any network analysis, then you should have checked for all these things. One of the things that I wanted to show you is the road graph, which is really the shortest route. But I think this version of QGIS doesn't have the road graph, which allows you to find the shortest route. But then you can always check in the plugins. You go to plugins menu and you can type in the plugin of interest. So this is least cost path. I don't know if that's really what we want. It could deal with raster data. Okay. Find the least cost path with giving cost raster. So it has to deal with raster data. Is that okay? Which is actually like the DEM. Okay. All right. So I think they've taken the road graph out of it, but yeah, guys, I think every good thing must come to an end, and basically you can keep on exploring. Are you okay? The lecture, every tutorial you've done, even at the master's, whatever PhD level, is supposed to open a door for you. You don't stop where I stopped. You just keep on trying. Are you okay? And it should be just fine. It should be just fine. What if we had used a road graph anyway? All you do is you just say, I'm starting from here, I'm ending from here. Show me the shortest path. Like Google does it, which I think we've all seen it. So I wasn't going to show you anything spectacular. So this is it. This is all I got for you. Let me know what your concerns are in the next 5 minutes or 2 minutes. Let me know, because I think the next thing you see that I'm giving you a mark, Ayaki, for the whole course. And then it will be fair that you ask me anything that is a challenge, a border. In the next 2-3 minutes, we can handle it a bit. And otherwise, then we say goodbye. Yeah.
So how is the end of summer exams going to be like?
The end of summer exam is going to be based on a scenario, a case study. So normally it's a project. So it's like you've been given a project and you're supposed to answer questions on it. How do you use GIS to actually solve those questions? Every question that I'll ask you will actually point to a certain part of the notes. You need to take your time, think about it, and identify it. And once you found it, because of plagiarism checks, most of my notes are online. So you can easily be, caught for copying, without authorization. So just make sure you first find the part of the notes that I'm actually asking the question from. And then once you are good, I want you to also identify, think through it and then write something about it based on your understanding. Are you okay? So I think that is it. We are doing an open book and an open book exam. An open book exam is open book exam. Okay. You can easily get it wrong. You can easily get it wrong. Exam means that you can easily get it wrong. That is what it is. Okay. So please, you need to understand what you've been taught. But I think I have a strong feeling that most people in this class understand what I'm talking about, especially those who have been present from the very beginning, except a few people. I can see them here. I mean, honestly, I can see those who haven't been coming. I mean, honestly, I don't think you can trick me, but I see people who didn't show up.
Hello, sir. Hello, sir.
Hello.
Yes, sir. My complaint is about the AIT and standards.
Right.
And we have not been receiving some assignments from you, and we want, if you can help us and give us an assignment that can cover the whole coursework. Other than that, if you are left with only the mid-semester, the mid-summer and the end of summer exams, we end up having a very bad grade at the end of the day. So if you have time, you can give us an assignment, upload it on Lemmas, and then we solve it and then send it back to the Lemmas.
Okay, so you think you want more assignments?
Yes, please. You can give that will cover the 30. Will cover the 35 marks. It's 35 marks. So
no, I think so.
You do that.
I think that one is not really something I have to discuss with you. Yeah, the way I award the marks is per my discretion. Yes, I can decide to score you based on the way you are talking right now. Okay. So I think AIT has standards, but of course, knowledge is not really You know what I'm saying? You can't really box it like that. Someone may have the knowledge, understand the whole thing, but it's up to the person who is doing who is examining. It's up to the person who is doing the examination, the examiner, to determine. Are you with me? All right. So please, let's follow that. The fact that your teacher is your actually